So we are going to start with the very first chapter, that is vectors. Now this chapter is not really important for your NEET exam because only 1 or 2 questions come from this chapter, but it's very important to create your basics, which is going to help you throughout your physics journey. So this chapter, vectors. So first of all, we'll start with some definitions which are not really important for you, but you should know. So I'm going to just read them out for you. What are physical quantities? Now physical quantities actually means the quantities which can be measured. That's the keyword for you. The quantities which can be measured and by which we describe the various happenings of this physical world, and the laws of physics are known as the physical quantities. Now on the basis of direction, we divide the physical quantity into 2 types, that is the scalar quantities and the vector quantities. On the basis of direction, I said. So the scalar quantities are going to be the ones which do not have a direction, and the vector quantities are the ones who have a direction. Both of them have the magnitude. So for definition wise, quantities which require only magnitude for the representation, no need of direction, are known as the scalar quantities. For example, mass, time, temperature, speed, distance. Now these quantities follow the rules of ordinary rules of algebra. The basic rules that we use in mathematical calculations are the ones that are applied over here as well. What are vector quantities? Vector quantities are actually the quantities which require magnitude as well as direction for the representation. For example, displacement, velocity, acceleration, force, momentum. Now these might sound new to you. This is exactly what physics about, all these quantities. These vector quantities follow the rules of vector algebra, which is little different from the ordinary rules of algebra because they follow, or they take into consideration, direction. I'm going to give you a very little example. If you don't get it, don't worry about it, because we are going to study this distance and displacement in even more detail afterwards. So there's this example. There's a person standing here at the origin point, and he's moving 20 meters towards the left, and then he goes 10 meters towards the right. So what is the distance that he has traveled? The distance is a scalar quantity, as we saw here. Distance is a scalar quantity, so it doesn't really depends on the direction. So he moved 20 meters and then he moved 10 meters. The total of 30 meters is what our answer is going to become when we say distance. If I ask what is the displacement of this person, now displacement exactly means the change in the position of the person from initial to final, and it considers direction as well, as it is a vector quantity. So we are gonna see the initial position was here or at the origin. He moved 20 meters towards the left, somewhere around here he reached, and then he turned around and moved 10 meters towards the right. So this is a final position, this is an initial position. How much has this person moved? If I say 20 minus 10, simple, it's 10 meters. So 10 meters towards the left, because initial was here, final is here, towards the left. So he moved 10 meters towards the left. That is our displacement. Yeah, this is a simple example. This is how vector algebra differs from the normal ordinary algebra, because it takes into consideration the direction. Now, if we have studied some quantity, a vector quantity or a physical quantity, we should know how to represent it. Simply, a vector quantity can be represented by an arrow over the symbol of the vector quantity. Just as I have done here, distance with an arrow overhead, velocity with an arrow overhead, force with an arrow overhead represents a vector quantity. Now when I want to represent the magnitude of this vector quantity, I'm simply going to put 2 bars alongside it, and it is going to represent the magnitude of the vector quantity. Simple representation. We don't really need any details about it, but if you want to graphically represent the vector quantity, you can do with a arrow. Draw an arrow which is gonna represent straight line arrow, whose length is gonna represent the magnitude, and the direction of the arrow is gonna represent the direction of the vector. It is gonna have a start, initial or origin point, and it is gonna end with the arrowhead, ending final or terminal point. This is a graphical representation of a vector quantity. Now we're gonna read some properties of the vector quantity, which is very important for you, because this is gonna help you solve the questions. If a vector needs to be changed, we can either change the direction, or we can change the magnitude, or we can change both of it. Simply because even if we change the direction, the vector changes, because it really depends on the distance, on the direction. The second property is vector can be shifted parallelly. For example, this is a vector. I moved it here, then I moved it downwards here. The angle from the origin didn't change, so and even the length doesn't change, so the vector is not changed, it's exactly the same. So vectors can be shifted parallelly. Third, if a vector is rotated at an angle other than the integral multiples of 360, that is the 2 pi radian, then the vector gets changed. What do I mean here? Integral multiple of 360 is like 360 or 360 into 2. This is what I mean when I say integral multiples. I represent a vector with making an angle theta from the origin. If I move exactly rotate it by 360 degree, it comes at the same position. Okay, but if I rotate it by 180 degree, something not an integral multiple of 360, then the vector's direction got changed. Even though the length didn't change, the magnitude didn't change, but the direction got changed. So if I rotate it with any angle other than the integral multiples of 360, then the vector gets changed. The fourth property is if a vector is multiplied by a positive number, direction remains same and magnitude gets multiplied. If it is multiplied by negative number, direction gets opposite and magnitude multiplies. It's simple mathematics. For example, this is a vector A. If I multiply it with 3, the length becomes 3 times and the direction remains same. If I multiply it with -3, the direction gets exactly opposite. The fifth property is vector algebra must be followed. Okay, by example, there is electric current, rules not followed, it is not a vector. If some mathematically, if we seeing the conclusions that are coming with through experiments and all of these activities that we do, if it gets a perfect answer with the normal mathematical algebra and it doesn't follow the vector algebra, then it is not a vector. For example, electric current, you will be surprised to know that electric current though have a sign plus and minus, but it is a scalar quantity and not a vector quantity. So these properties are not much used to you. No one is gonna ask you a question saying which of the following is not a property of vector, but you should know for your general knowledge, for the basics that you really need. Now what comes a type of vectors. Some of most, like I have seen questions in NEET coming up like these, they have given two vectors, they have drawn two vectors, and then what are these negative vectors or equal vectors or opposite vectors. So this is kind of a topic which might you consider important, a question might come up on this. So type of vectors, for example, equal vectors. What do you understand by equal? Vector having equal magnitude as well as the same direction. So A and B vectors, they have the same direction and they have the same magnitude, so they are equal vectors. Then the second comes unequal vector. Simple, that's so simple, like even the word says itself, either they have a magnitude different or they have a directions is different or they have both different. Magnitude different, one is a bigger one, other one is the smaller. In length, direction they point out in different directions, and both different can even be possible, multiple possibilities can be there. Then are parallel vectors are the ones that have the same direction as seen in the diagram. Then are anti-parallel vectors that have exactly opposite directions, like this one. Next one is negative vectors, opposite vectors. Negative vectors means the ones which have exactly same magnitude but they have opposite directions, not different directions but opposite directions. Like for example, this vector A here and this vector B here, they have equal lengths but they differ in the directions. The arrowhead points in the exactly opposite direction, 180 degree angle. So these are opposite vectors or negative vectors. Now the question might come up like this, that they have drawn this is the example given to you. These are two vectors. What are these? Are these unequal vectors? Yes, every negative vector is going to be an unequal vector because they differ in direction. So yes, this is correct. Are they anti-parallel vectors? Yes, they are anti-parallel vectors as well. They have an angle of 180 between each other. They have negative vectors. Yes, they are negative vectors because they have equal magnitudes but they have opposite direction. They are negative vectors as well. And the fourth option, to your surprise, is not all of these but it is none of these. Now what are you gonna choose out of all four? Which is the most specific one? Are every negative vector an unequal vector? Yes. But are every unequal vectors a negative vector? No. Unequal vectors can be one with different magnitude as well. So this is not a specific term for this. If I have to choose something very specific for this situation when they have exactly equal magnitude but opposite directions, then we are going to go with negative vectors because they perfectly satisfy the definition of negative vectors. So the answer for this is going to be negative vectors. If I go to the sixth type of vector, it is going to be co-initial vector. What do you mean by initial? Something starting point. Co means same starting point. The ones which have same starting point are known as co-initial vectors. Then we have co-linear vectors. Co-linear vectors, linear means a line. So the vectors which lie on a straight line are known as collinear vectors. Then we have coplanar vectors. Coplane, co means same, plane means a plane, like a wall is a plane, the floor is a plane, so lie on the same plane. So two vectors are always coplanar. For example, you can always make a plane between two vectors, like if I've drawn one plane here and one vector here, so this is in the plane of my screen. Okay, this is the plane of the screen. If I would have made a vector pointing out of the screen and a vector pointing out of the screen and other vector in the plane of the screen, so that is going to be a vector pointing out of the screen and other vector pointing in the screen. It is going to be a plane that comes out of the screen. Okay, so two vectors are always going to be coplanar. Now the third type of vectors are going to be concurrent vectors. So the next type of vectors that we're going to study are the concurrent vectors. The concurrent vectors are the vectors that pass through a common point. For example, these three vectors pass through a single common point. Then we have unit vector. Unit means 1. Everyone knows what unit means. So any vector which has a magnitude equals to 1 is known as a unit vector. Now we have a specific way to represent these unit vectors. We don't put an arrow over their magnitude. We either put a cap, this triangular invert V shape, over the vector, over the quantity symbol. This is known as cap. So every unit vector is represented by a unit cap. Now we have some standard unit vectors and we have some normal unit vectors. Every quantity has a vector, has a unit vector. So they are normal unit vectors. What are standard unit vectors? These are I cap, j cap and k cap. These are standardized to represent a particular direction. I cap represents the x direction, whereas minus I cap would definitely represent minus x direction. J cap would represent the y direction and k cap simultaneously represents the z direction, that is an axis which comes out of the plane and which goes into the plane. For you it is going to be out of the screen and into the screen. Now for example, a person has an initial point 0 and its distance, like its displacement, is 5 k cap meters. Okay, and this is the way how we represent vectors. The displacement is 5 k cap meters. What does k cap means? It has moved 5 kilometers in the z direction, that is out of the screen. Simple as that. Now next is polar vectors. What are polar vectors? Polar vectors have an initial point and a final and a final point, that is point of application. For example, displacement and force. We know if there's a box put in front of you, how are you going to put the force on the box? Definitely some force that is going to touch the box is going to be the force that we are going to apply on the box. So polar vectors are the ones which have a final point, that is the point of application. Then we have axial vectors. What are axial vectors? These are the vectors that are along the axis of rotation. These vectors are used in rotational motion to represent the rotational effects. The direction of axial vector can be determined by the help of right hand thumb rule, according to which turn the fingers of our right hand along the direction of the rotation, then the direction of the erect thumb represents the direction of the axial vector. Okay, what does this mean? We use it in terms of rotation. All the objects that show rotational motion, and they definitely have a vector because rotation has a direction. The rotating body has a direction, so it is definitely going to be represented by a vector. So what vector is going to represent it is known as the axial vector. How we going to determine the direction of this vector is by this right hand thumb rule, where we are going to move our right hand fingers in the direction in which the object is moving, that is either clockwise direction or anti-clockwise direction, and the point of our thumb finger is gonna tell us the direction of this axial vector. Now we have this now I have a question for you. We have this two forces, F1 that is in the x direction and F2 that is in the y direction. Both of them have a 10 Newton amplitude. Now tell me which of the following are true and which of the following are false. Let me just repeat for you the answers for you for a second. Now we are going to do which of the following are true and which are false. Force F1 with a bar along it, that is, it represents magnitude. Magnitude of F1 is equals to F2. Is it true or false? True, both of them have a 10 Newton magnitude. Force 1 is equals to force 2 without bar, that means it represents vectors. Now the direction magnitude may be same. Are the directions same? No, the directions are not same, so this is going to be a false statement. I have inserted a cap on it, except for that, in place of that arrow, so F represents unit vector. All the unit vectors are going to have the same magnitude, that is equals to 1, so this is going to be a true statement. Does the F1 cap equals to F2 cap without the bars? No, it is not equal to, because the directions are different. Have I said I cap equals to J cap? No, I cap represents the X direction and J cap represents the Y direction, so this is a false statement. And the next term, that is the magnitude of I cap is equals to J cap, yes, it is true, it is equal, so it is a true statement. So this is a simple question for you all. Now we are gonna come on another thing, that is known as angle between two vectors. We are always gonna consider smaller angles, okay, and at tail to tail, and that too at the tail to tail contact. That means this is one vector and this is another vector, so it has two angles between them. This is the one angle and this is another angle. What are we gonna consider? We are gonna consider the first angle because it is a smaller one, and we're gonna make an angle between their tail to tail contact and not the head to head contact. If I'm gonna make the head to head contact, it would look like something like this. Now this is not the angle that we are going to consider. We are going to consider the angle between them as tail to tail contact. So these are the standard rules that we have to follow when we are considering what is the angle between two vectors. These are some examples to illustrate the same. These are two vectors with an angle 30 in between the tail to tail contact, so our angle is going to be 30.